The Wright State University is located at Dayton, Ohio, and which is just 5 minutes to the Wright-Patterson Air Force Base. And the name is after the Wright brothers. And we have about like 18,000 students enrollment in this university. Primarily, my funding from the Department of Defense, and most of them are from the Air Force. We are working with the Air Force Base and trying to design the small size micro-air vehicle. The size is actually the dragonfly size. So, but in order to make it fly, it's not easy because at this kind of size, you cannot just use the conventional aircraft design idea to design your micro-size UAV. So you have to go to the nature, find the answer. For instance, we targeted the dragonfly recently and trying to build the dragonfly-inspired micro-air vehicle. But in order to replicate something in nature, that's not an easy job to do. So we use ANSYS for studying the structural properties of the insect wing. So then what we do is we take the live dragonfly and let it lie down on the table and apply the force on the wing. Then we use the information there so that we use the ANSYS to select the materials and the structures and to exactly mimic that kind of bending. So that's what we use the ANSYS. Yeah, it gives us lots of options on selecting the existing materials and for building up the artificial wing so that it can replicate the real wing in nature. The unmanned air vehicle is a very large topic in the Air Force study because it involves lots of engineering problems like mechanical engineering and materials engineering and electrical engineering. There are lots of things. But the part of what I am working on using ANSYS is including two parts. The first part is the fluid dynamics. The second part is the structural mechanics. And in terms of fluid dynamics, we are using the ANSYS to study the engine, who is the energy source for the unmanned air vehicle. And also for the structural mechanics part, we use the ANSYS to do the structural analysis. And also we use that one for the design the smaller UAV, and also the assist the students for doing the senior design, so on and so forth. What ANSYS helped us, okay, you might have 100 design plans. So then, but if you do it in laboratory one by one, if you can do it in 1 day a plan, you need 100 days. Okay, but ANSYS, if we use ANSYS for doing the design, then you can open like 20 computers to do the design for you. Then in 5 days, you can finish the whole design to check all kinds of combinations and see what's going on. So ANSYS definitely helped us reduce the design cycle and speed up the design, and also provide the lots of options for the engineers to polish their design. ANSYS definitely is leading this kind of simulation software, this market, because they have so many choices for the researchers and engineers to use for doing their design, and they also have lots of innovative thoughts, and they put them in the products like Workbench. That one integrate the multiphysics softwares and the design softwares and optimization tools together, and so that to make the people can just use the one product and do lots of things they want. So in terms of leadership and the innovation and productive, yeah, definitely the ANSYS is doing the very good job. ANSYS is a versatile software, can be used in lots of engineering aspects, including the mechanical engineering, materials engineering, biomedical engineering, and electrical engineering, and more. And its options to the researchers, to the engineers, and also its capabilities of solving those kind of real engineering problems give the user lots of choices, and so that it's a dominant software in the engineering applications.